to introduce how to model the first level, means the single subject level activation. So in this step, we already finished the pre-processing. We have the smooth data, and also extract onset. We have the estimated head movement. So here we click this button, specify first level, and the directory specify you select this subject, the analysis folder. Done. Unit of design, here we select second, because in our onset file, all the units are in seconds. The interscan interval is your TR. So in our data, the TR means the time to acquire one volume, means the one frame is 1 second. So here is 1. And data and design, we have 2 rounds. So we click new subject and selection twice. And here in each subject, under each subject and session, the scans, we select the smooth data of that scan. So for example, we go to the run 1, and here S. So apply the filters to select all images with the file name begin with S. Select all, done. So here under the second subject and session, we select all of the smooth image for run 2. And go back to the first run, the multiple conditions highlight here, specify. So go to the behavior folder, onset. We select the run 1 onset, that's the one we just extracted. And also for the same thing, multiple conditions. For run 2, we select onset, run 2 onset, done. And then we click the multiple regressors. So here we need to select the head motion parameters. Specify, go to the run 1 folder. So here you can just select either the .mat file or the txt file. What we need is the .txt file. Done. And also do the same thing for run 2. Go to the run 2 folder, txt file, done. So that's it, and then we press run. See the design metrics. This is a regression model. So the Y, the independent variable, is each voxel in the images, and each column is a predictor with a slightness as the intensity of the value, the magnitude of the value. With the brighter color means the more positive value, and the gray color or black color, darker color means a more negative value. So here we have 11 regressors convolved with the HRF, means the hemodynamic response curve, to model the brain activity associated with each kind of type of event. And then we have 6 nuisance regressor to model the head movement, which are not convolved with the HRF, because the head movement just can induce noise, not brain activity. And then we need to estimate the coefficients of each regressors. So to do this, click here, estimate, this button, and select, go to the analysis folder, select the spm.mat file we just generated. Done, and press run. Okay, so it's running. Okay, so it's done. And the last step of the first level analysis is to define the contrast. Means here we are interested in one condition, the activation under some condition, one condition, or the difference between conditions. So contrast is the planet comparison. We need to define which condition minus which condition or which condition itself. So to do this, we click to do the contrast. We click Batch, SPM, Stats, Contrast Manager. So first we need to select spm.mat file. Just select this file we just estimated. And contrast section, now we just need a T contrast. So here in the PowerPoint, page 41, I list all the contrasts we need to define. So here the name, right here is for the name, Q or minus baseline means the activation associated with the Q on that Q phase. It doesn't matter which condition there. So the weight vector, so here for this 1/3 0 0 0 1 2 3 4 5 6 7 8 zeros. Done. And replicate over section, we choose this one, replicate and scale. So means you don't need to define run 1 and then run 2 specifically. You can just define just one run. And here you can select delete the existing contrast if your purpose is to define all of the new contrast, not just to add a new contrast. So we finished the first one. To define the second one, right? To do this again, click T contrast again, Q reward one. Here means we just want to know the Q, the reward Q, right? The activation associated with the reward Q during the reward phase. So replicate and scale. Q neutral. So yeah, just if you want to define the following contrast, you just follow what I did just now. So now here I'm not going to finish all of them, and just press run. If you're done, just press run. So it's done very quickly, and then yeah, we are done for the first level analysis. To view the result of the first level analysis, so you click here, the results. Select the spm.mat file for this subject. Done. And then you can see the contrast manager. Here you can see the contrast we just defined it. We just defined 3 contrasts. So here the top row is, you can see that the contrast weight vector means here we compute the weighted sum, right, of all of the coefficient across the coefficient we estimated for these regressors. So here we compute the average, right, of the first 3 contrasts, means the first 3 regressors, means of the Q regressors, and this regressors means the Q regressor for round 2. We compute their average, which defined as the Q minus baseline. So if you want to view this, select this and click done. Apply mask. So here we don't need to apply, just choose none. And here is the p-value to control, means for each voxel, what's the p-value of the t-test. So in the contrast, we just apply a t-test to estimate whether the estimated contrast is significantly greater than 0. So here we don't need the p-value adjustment to control. This is to control for the multiple comparison. So we don't need it for the first level, because first level is more, we choose a more liberal threshold just to take a look whether or not we have some meaningful activation. So none. And this is the p-value we want to select. So more liberal, we can just select 0.05 at beginning. We can change it later. So extend threshold means, so for the fMRI, we are going to activate a specific brain region, means a cluster, means a bunch of voxels grouped together, not a single voxel randomly in the brain, because this is the way our brain activated. So the extend voxel means how many voxel they activate, how many activate voxel they grouped together in the physical space. We can treat this one as a real activation. So if you have strong activation, means a cluster of voxels should be activated together around an area in the brain. So here, because we want to define a more liberal active threshold, so we just choose 0. So here we can overlay our result on our template, the template we used, which is the age-specific template. So it's here, template, done. You can see here we have activation. If you define the section here, section, and select template. If you define section already, next time you can just select preview section, and then you don't need to choose the template again. So in this is the glass brain. Just give you 3 section view of the brain activation. This is the design matrix as the contrast weight. So here we estimated the threshold T image to a brain template. So here we see we have for the Q phase, we have activation at ACC, and activation at insular cortex, and yeah, that's it. So if you are not familiar with the brain area, what you can do just to do more practice. So here you can see we have some artifact at, this is the eyes. So because for this video, this basic pipeline, I just do the very minimum, follow the standard pipeline to do the data processing. I didn't control the activation outside the brain, but in my revised pipeline, so I have more complicated processing and exclude those non-meaningful brain activations. So that's it. Then you know how. And then if you want to change to another contrast, you just click here, contrast, and select the contrast you want to view. So here we define the template already. So just preview section, change to another section, show another result. If you want to change the threshold, for example, we want to change single Warsaw level at 0.01, which is more conservative. Just click the change. For example, 0.01 or 0.01. Up to you, right? So here you can see if we have the threshold as p is smaller than 0.01, and then we have less area survived. And if we change to 0.01, so means then we have, right, we further restrict the activation, this more significant activation. So now you know everything for the first level analysis.